Herzlich willkommen zum heutigen Webinar mit dem Titel Durch Korrelation und Auto-Investigation mehrstufige Cyber-Angriffe detektieren. Mein Name ist Christian Grob, ich leite den Geschäftsbereich Security Services bei Avantec und es freut mich, dass wir heute Ian Forrest von Hunters, Vice President Sales Engineering, mit dabei haben. Ich starte mit einer kurzen Einleitung ins Thema und werde dann aber den größten Teil an Ian mit der SOC-Plattform-Demo auch übergeben. Seitens Avantec betreiben wir ein umfassendes Portfolio an Managed Services und Produkten, um Sie mit Ihrer Cyber-Defense zu unterstützen. Heute im Webinar geht es vor allem um das Thema Managed Security Analytics beziehungsweise die Technologie von Hunters, die SOC-Plattform, die wir als Teil vom Service einsetzen. Wir hören immer wieder von verschiedenen Herausforderungen im Bereich Security Analytics, vor allem auch mit dem Einsatz von klassischen SIEM. Und ich möchte auf 3 Herausforderungen, die wir am meisten hören, gerne kurz eingehen. Das erste Thema, was immer wieder aufkommt, ist die Threat Coverage bzw. die ungenügende Threat Coverage. Trotz aufwendigem Use Case Engineering werden oft die Erkennungsraten nicht gut genug. Ja, das merkt man dann in Red Teamings oder halt im schlechtesten Fall auch bei einem echten Angriff, dass man hier gewisse Lücken in der Coverage eben hat. Ein weiteres Thema ist die Transparenz. Man weiß oft gar nicht genau, was ist eigentlich die Abdeckung, welche Taktiken, Techniken zum Beispiel der Angreifergruppierungen werden überhaupt erkannt. Und der Ansatz wird oft auch der Dynamik der Bedrohungslage nicht gerecht. Also die Use Cases sind schnell veraltet und entsprechend auch nicht mehr voll funktionsfähig. Das zweite Thema ist das Thema Logvolumen bzw. Kosten aufgrund des Lizenzierungsmodells. Die meisten Lösungen lizenzieren nach Logvolumen. Das bedeutet, je mehr Logs, je mehr Kosten. Und das führt dann oft dazu, dass relevante Logs nicht mehr in die Security Analytics mit einbezogen werden, weil es schlichtweg nicht finanzierbar ist. Und auch von der Planung her ist es einfach schwierig, dann auch über mehrere Jahre das überhaupt planen zu können. Das Logvolumen steigt aus unserer Erfahrung so pro Jahr um 50% im Schnitt, also relativ stark. Die dritte Herausforderung ist vor allem im Bereich der Alerts. Es sind zu viele Alerts, auch zu viele False Positives, was zu einer Überlastung der entsprechenden Teams führt. Und auch die ganzen manuellen Analysen führen einfach zu einem hohen Zeitverlust mit diesen Alerts. Was den Fokus dann eigentlich auch von den wichtigen Alerts ablenkt, die man eigentlich analysieren sollte. Was wir seitens Avantec für unser CDC eine Lösung gesucht haben, die eben genau diese Themen adressiert, sind wir auf Hunters gestoßen. Und ich möchte kurz auf die 3 Punkte eingehen, weshalb wir denken, dass diese 3 Punkte genau adressiert sind. Bezüglich Threat Coverage ist es so, dass das Detection Engineering ein integraler Bestandteil von der Plattform ist bei Hunters. Das heißt, 75-95% des Detection Engineerings kommt schon mit, wird durch Hunters gepflegt, getestet und auch immer wieder entlang der Bedrohungslage weiterentwickelt. Es gibt auch volle Transparenz, was erkannt wird, entsprechend einem Mapping auf das MITRE-ATT&CK-Framework, welches auch dynamisch einsehbar ist. Also man sieht jederzeit, mit welchen Logs werden welche Angriffstypen erkannt. Das Log-Thema ist ebenfalls gelöst, und zwar durch ein anderes Lizenzierungsmodell, eben nicht volumenbasiert, sondern host-basiert mit unlimitierter Log-Ingestion. Das ermöglicht dann auch eine Planungssicherheit auf mehrere Jahre hinweg. Und das dritte Thema, die Reduktion von diesen Alerts, das findet statt durch Korrelation, Kontextualisierung und Auto-Investigation. Das werden wir dann nachher von Ihnen in der Plattform sehen. Durch diese Automatisierung sind im Prinzip L1 und L2 SOC-Tätigkeiten zum allergrößten Teil obsolet, und diese Teams oder auch SOCs können sich dann entsprechend wirklich auf die relevanten Alerts konzentrieren. Unseren Kunden stehen 2 Betriebsmodelle zur Verfügung. Einerseits das MSSP-Modell und das Resell-Modell. Im MSSP-Modell wird die Plattform als Teil unseres Managed Detection und Response Services zur Verfügung gestellt und unser Cyber-Defense-Team übernimmt die Analyse, Triage von sämtlichen Alerts 24/7 mit einem definierten SLA. Wir führen auch tiefergehende Investigations durch, leiten Maßnahmen gemäß Playbooks ein. Im Service erhalten Sie auch 24/7 Zugriff über eine Hotline auf unsere Experten. Wir überwachen die Logs, wir stellen die ganze Konfiguration auf dem Tenant sicher, unterstützen auch mit dem Onboarding in die Plattform und so weiter. Im Resell-Modell, das ist das Modell, wenn Sie ein eigenes SOC haben, dann stellen Sie die meisten Aktivitäten selber sicher. Sie beziehen einfach die Lösung als Subscription in diesem Modell. Zusammengefasst, wenn Sie ein eigenes SOC haben, dann wäre das Resell-Modell passend. Andernfalls wäre das MSSP-Modell mit unserem Team das Richtige. Wir kommen bereits zum Teil von Ian mit der Vorstellung von der SOC-Plattform. Welcome, Ian.
Thank you, Christian. I appreciate it. I'm excited to share with everyone about Hunters today. As Christian mentioned, I'm Ian. I'm our VP of Solutions Engineering here at Hunters. And for those of you that aren't familiar with Hunters, we're going to focus on some very specific things today on how Hunters and specifically how the auto investigation process that Hunters performs for you really assists and helps uncover correlations and assist with investigation and making the SOC team much more efficient, and also uncovering attacks that might otherwise be very difficult to uncover on their own. But before we do that, let's do a little bit of basics on kind of what Hunters is and why it exists. We look at the history of kind of like the SOC evolution and the tools that have been available. Originally, we started with just log collection, just collecting logs all in one place so that we had some place to be able to search them. And, really, realistically, it was an IT tool. Why is the server tipping over? Well, I need all the logs in one place instead of going to each individual server and trying to, grep the log records and figure out like what could be going wrong. And very quickly, it became obvious that this could be useful for security teams. And that led to the birth of the SIEM. And the promise of the SIEM was, we have all these logs in one place, so we should be able to create alerts, with the log data. In theory, it worked. We were able to create some alerts and create some correlations, but ultimately, the SIEM has kind of resulted in a number of different things, but alert fatigue, endless rule tuning, ingestion maintenance, and manual investigation. And what that all means is that a lot of teams are spending more time maintaining their SIEM than they are actually leveraging the results from the SIEM. And so, that's where Hunters comes in. Hunters is designed to really kind of make good on the promise of SIEM and say, hey, our goal is to deliver a queue that is very manageable and that provides actionable alerts without all the overhead of the maintenance and the tuning and the ingestion, data mapping, and all those different things that have caused the SIEM to be such a headache in so many different organizations. And we do that through a process of, smart automation and AI mixed into that platform to really assist with all of those different processes. So if we think about it from like a very high level, like our core pillars are data detection, triage, and response reporting. And ultimately, we want to be able to scale data to whatever level that our customers need. We recognize that as organizations adopt more and more technologies, and as those technologies become chattier because of increased number of microservices or because of the increased number of customers that you might have, like the amount of data that we're seeing in customer environments is massive. So you need a backend that can scale to that and doesn't require that customers make trade-offs between do I ingest this data because it's valuable from a cyber perspective, but it's very expensive for me to ingest, or do I not ingest it because it's very expensive and I really can't afford to do that? And so we find it's important to be able to have a data lake that allows for scale like that without having to make cost trade-offs. So do it in a very cost-effective manner. We'll talk about how we do that in a minute here. Detection, again, the big thing with detection is how do we make sure that detections are useful and usable and decrease that onboarding time so that you can get up and running with the detections right away, instead of spending a year trying to tune your data and tune your detections to make sure that they work for you in your environment. 3 is the triage and investigation. So right now that I have a detection, what help can we provide to help you determine whether something is or isn't malicious in your environment? A lot of people are trying to use SOAR tools for that, but SOAR creates its own set of overhead. Now I have a playbook that I have to manage, and anytime that I change technology, I have to change my playbook, and I have to hire developers to basically engineer that playbook and build in logic to it. We take a different approach to that and say, hey, let's do as much of that triage and automated investigation for you without requiring a playbook. And on top of that, try to provide insights that will determine whether an alert is actionable or not. And finally, just making sure that you're able to report on those metrics, and not only report on them, but be able to interface with the tools that you need to be successful, whether that be, a ticketing solution like ServiceNow for anything that you need to for like a case management capability, or if you need to interface with other teams like IT to, take somebody's device and reformat it, all these different things. And ultimately, our goal is to reduce false positives, improve your, mean time to detection, and boost your efficiency in the team. And going into a little more detail, how do we do that? This slide really represents like the data lifecycle within hunters. So kind of starting with the raw data on the left-hand side and the outcomes of what we do with that data on the right-hand side. So if we go, left to right, just like I mentioned, we start with, the data sources. So what are the data sources that we're ingesting data from? And it's all the things that you would come to expect, your EDR, your IAM solutions, your cloud, your firewall, your email. Let's ingest all of that. But the key thing that we want to make sure is that we're doing it with as little effort on your team as possible. And so the way hunters ingest data is we ingest it in its raw format, and we try to do it whatever the path of least resistance is. So what does that mean? Like if the product that we're interfacing with has an API, we'll use the API. If it uses webhooks, we'll use webhooks. If it uploads data to S3, we'll ingest the data from S3. And we want it in its raw format. We're not asking you to do any kind of data wrangling or manipulation of that data to a common schema in order for it to be effective. In fact, what we are doing is we're normalizing it to a common schema as part of our ingest process on behalf of you. And the schema that we've aligned to is the Open Cybersecurity Schema Framework, which is OCSF. It's an open source framework that number of different vendors are adopting. I think the number is over 100 at this point. And there's like 600 different contributors. And the really great thing about using an open source schema like that is it's extremely well documented. It's updated regularly. And ultimately, it's going to lead to easier interoperability between us and any other product that might exist out and that also operates on OCSF. So that's one component. And the other component is that we're using an enterprise data lake on the back end. So in this case, we're showing Snowflake here. And what that enables us to do is it enables us to scale to that data volume that we were talking about. Data traditionally has been such a problem, especially in the SIM places. How much time am I spending trying to figure out how do I make sure that my SIM doesn't tip over because it's too much data, or how do I make sure that my spend on my SIM isn't too high because I'm ingesting too much data? And really, we offload a lot of that work to Snowflake. They've got a team of developers, an army of developers, and billions of dollars of investment to be really, really good and really, really efficient at data volume. And so, in that manner, we're able to scale to massive amounts of data and do it in a very cost-effective manner. So once that data is in, we'll run our detections on it. And I mentioned, our detections are designed to work out of the box and designed to really help you onboard and get value right away. The thing that we don't want is you to reinvent the wheel on something that's already been done a million times before. An example of that might be like a pass the hash type detections. This is a very common problem. It's something that most organizations want to detect. And there's no reason for every organization to make their own implementation of it. We have a very good implementation of it, and we want you to be able to leverage it. And a key thing that we're doing with our detections is we are monitoring the efficacy of those detections across all of our customers. So what does that mean? Every detection will ultimately yield a confidence score. That confidence score will say, how likely is this to be malicious or not? And what we're doing is we're comparing the confidence score that we're showing to our customers and the outcomes that our customers are assigning to those alerts that are generated as a result of those detections. And when there's a discrepancy, when a customer is saying, hey, you said this was high confidence, but we're marking this as, benign, or vice versa, we're marking it as malicious and you said it was low confidence, we're continuously reviewing for those discrepancies and making changes to either the detections or the way that those detections are triaged to ensure that we're closing those gaps and getting that alignment. And all of that's happening in place. So a big difference there is, lots of companies will maybe publish new versions of the detectors, but it's incumbent upon you to put in your environment and you to test it and make sure that it's working. Instead, what we're doing is we're doing that tuning in place so that you don't have to, and you get the benefit of the research that our team is doing, and you can really focus on the things that are bespoke to you. So the next piece is the triage and investigation piece. And this is the piece that we're going to spend the most time on today in the platform when we get to the demo. But ultimately, what we're doing is three core different things. And one of them is enrichment. So we're doing the investigation. We're saying, okay, well, we've got the alert, but what key values are in the alerts and what kind of questions can we ask? And then we're doing scoring. So we're using the enrichment and using the original data and the alert to score it and adjust the confidence either up or down to decide whether something should be an alert that's investigation worthy for you or maybe not be an alert that's investigation worthy and pull it out of the SOC queue. And the final thing we're doing is we're graphing the correlations of those in a graph database. And what does that mean? We're looking for the common threads between the events that are generated as a result of our detections, and then tying those together into attack stories. So we enrich at the alert level to provide context at the alert level, and then we use the graph-based analysis to provide context at the attack level to go from an individual alert to an attack and illustrate very clearly the attack path that a customer took or that an attacker took inside your environment. And ultimately, what does that yield? It yields a very manageable SOC queue that your team is able to effectively triage and respond to the most important things in your environment, and without having to sift through a bunch of noise. Really reducing that signal to noise or improving that signal to noise ratio. So I'm going to dive into the triage and investigation piece just a little bit more to kind of give you some examples, and then we'll jump into the platform and kind of show how that manifests itself. But the first thing is, what is that auto investigation process that I mentioned? I mentioned it being kind of broken up into three parts: enrichment, scoring, and correlation. So enrichment is really about understanding more about the entities involved. As part of the process, Hunters is going to generate detections, and then we're going to extract the entities from it. And the entities could be users, hosts, files, command lines, you name it. And we extract it. And as part of that process, we're going to enrich it with both activity that we've seen related to that entity and also additional information. So examples, how prevalent is this binary in the environment? What does VirusTotal know about this binary? What's normal? Who are the normal users for this host? Where do these users normally log in from? Where was this IP, geographically located that we observed this activity from? All of these things that you may do in a SOAR playbook today, or you may do manually today, Hunters is doing automatically as part of its auto investigation process. That context, and you can see here, how that context is manifesting in the product. So we can see like the normal users for a device. We can see the prevalence of binary hash execution in the environment. We can see the login history for a particular user. And that context is really helpful. But the second thing is, okay, we've decided, okay, we've encoded our investigation process into the platform, but how do we take that and then use that additional information to change the confidence, to say, hey, yes, now with this additional information, I think that this is more likely to be malicious activity, or maybe I think it's less likely to be malicious activity. And there are a variety of different scoring rules that will fire as a result of the overall auto investigation process. And really, those scoring rules are broken down into two different things. There are scoring rules that are very specific to a detector, and there are scoring rules that are universally applicable. So an example of a universally applicable rule is like a virus total scoring model. Sure, we did the virus total lookup, but now let's look at the results of the virus total lookup and say, well, yeah, 60 scanners found this to be malicious. Let's increase the confidence of that detection. And, an example of something that might be very specific is, hey, I saw, some suspicious commands in this command line. That might be very specific to one detector related to, like, let's say, like bits admin jobs or something like that. And so those scoring rules are encoding like our expert cyber analysts' knowledge into the platform and allowing their assessment to happen before your team even has to look at the alert. And then finally is the correlation piece. And the correlation happens in two ways. Like, obviously we're correlating the other activity at the individual event layer, but we're also correlating the alerts together and correlating users and user identities together. So we have this concept of what's called person matcher. And one of the really challenging things in an environment is users can have lots of different identities. I could have a Workday identity. I could have something in, Okta. I could have, a Gmail identity. I could have an email address. I could have local user accounts. And how do we tie all that activity together to make sure that we understand, when we go look at a specific user, what's the scope of the activity happening with that user? And if we want to correlate events together, how do we correlate them by user if we so chose? And the way that Hunters is doing that is we're automatically identifying the identities associated with one specific person and providing that information to you, and also providing that to our correlation engine to facilitate that mapping process. And then the other thing is those attack stories that I was mentioning. So partially leveraging that person matcher capability, and then partially leveraging the extracted entities, Hunters can build a timeline of an attack in your environment and then visually represent that. And the way that we're doing that correlation is not with predefined rules where we say, hey, I expect, this behavior to happen, and then this behavior to happen, and then this behavior to happen, and then generate an alert. No, instead, what we're doing is we're just saying, let's extract the entities from every single event. And then after we've extracted them, let's look for the common thread between those events and tie them together organically. This results in something that's very, very interesting. If you are only looking for attack patterns that you're previously familiar with, you're only going to find stuff that you expected to happen. But attackers do stuff and they take unusual attack patterns all the time. And how do you detect that? That's what the Hunter's attack stories and correlation capability is designed to help you detect. Help you detect the unusual attack patterns, the things that you didn't expect to happen in your environment, and present it in a way that is very easy for an analyst to see start to finish. Here was the beginning of the attack path, and here is the end, and maybe even ongoing as these stories evolve, as more detection data is ingested. Okay, so that's the auto investigation process, and we'll take a very in-depth dive of that during our demo portion today. But how does this actually help customers? I mean, ultimately, we see customers ingesting vast amounts of data with tons of events that are being analyzed. They're not making that trade-off anymore. They're ingesting all the data that they have. Hunters, detectors are automatically able to generate leads and correlate entities, and then triage those automatically and promote the things that are most important to alerts, and then tie those alerts together into attack stories. And the numbers speak for themselves. Huge savings in efficiency and in noise reductions for our customers. And this example and the numbers that you see here are from like a real customer use case. Now, going into the demo, what are we going to look at today? We have an attack scenario. And in this attack scenario, an attacker is attempting to gain access to our cloud environment, in this case, Azure, via a password spraying attempt. We'll see that they're unsuccessful, but they're able to gain access to a host in our local environment via malicious email. And from that host, they're able to gain credentials and move laterally to our cloud environment. And from our cloud environment, they're able to get additional credentials that they're able to extract from an Azure deployment template. And then leveraging a third identity, they're able to run some PowerShell remotely for some reconnaissance and for some just kind of general awareness, like what do I have access to in this environment? And then finally, able to create a backdoor in a remote, in an Azure VM to establish persistence in the environment. And we'll see how across both on-prem and cloud environments and multiple different identities, we're able to tie those together into an attack story with the context that's required to be able to perform that investigation. And so we'll see how Hunters is able to support and scale for all the data necessary for this detections and story to be created. We'll see how those detections are mapped to the MITRE ATT&CK framework. We'll also see how those stories are correlated. And then finally, we'll see how the Hunters platforms assist analysts with investigating events as they start to go through them. So with that, we'll jump into a demo of the product. And what we'll do is we'll look at a couple of things. The environment here is not an active live environment, but there's a few things that I think we need to take a look at before we jump into that specific attack scenario. The first is the data sources. So how do we ingest data into Hunters? We can see that in this environment, we have 5 data sources that are active. They're not receiving a lot of data because the environment they're monitoring is dormant now. But a couple of key things here is we are monitoring the health of those at all times. We have a 24/7 NOC that monitors that health and ensures that all those detections, or all those data sources are up and running at all times. And that's really important because we know at Hunters that a SIM is only as good as the data that's being ingested. And if you can't rely on the data being ingested, then you can't rely on the efficacy of the SIM or the detections. The next piece is the data sources. So Hunters comes out of that box with a huge number of data sources that we integrate with. And these data sources, these integrations are installed out of the box. There's no versions, there's no apps. This is a cloud native product. All you have to do is go in, find the data source that you're looking for, hit the connect button, and enter in the required parameters, hit test, and then apply. And you've got that data source connected, monitored, and ready to start ingesting data. So that's part number one. The next is kind of our built-in detectors library. So we have well over 350 different detectors, many of those being Hunters unique detectors. And specifically, those detectors are covering the MITRE ATT&CK framework. And the really cool thing about this is that every detection that we have in the platform is mapped to the MITRE ATT&CK framework and mapped to a data source. So as you add more data sources in your environment, you can start to see how your coverage is improving across that framework. And you can see in my environment, there's definitely room to add more data sources. I've only got 5 in here, but you can see the areas where we have coverage and areas where we don't have coverage because we're missing a data source. And as you manipulate the matrix over here, we can see how that coverage would change as data sources are added. So with that being said, I'm going to skip into now what does an attack story look like in Hunters and how might we go and investigate it. So I have a story open already. And the story in particular is the one that we just went over. We have it starts with a password spraying attempt. And the thing that you'll notice is that we are visually representing the attack path, and we're showing you exactly how the different events that are generated are correlated to one another via the lines here. So we see these dark purple lines where we can see the value between the different events is exactly the same. And then we can see also in some cases, gray lines that indicate that there's maybe an indirect connection between those two. Maybe they're, a child to a parent process, or they're sharing the same process hash. So with the stories, we can then go ahead and investigate any one of these individual alerts that have been correlated into this story. So what I'm going to do here is take a look at this one. And this is my password spraying attempt. And the thing that I'm most concerned with this password spraying attempt is, were they successful? Did they actually, get into the environment? And so a couple things I noticed right off the bat is we see a scoring rule that was applied to this event, which increased the confidence of this. It started with unlikely, but the confidence was increased to possible. And why was it increased to possible? Because hunters is keeping track of the IPs that we normally see in an environment. And in this case, the IP address involved, this one here, is one that we haven't normally seen. So we're saying, hey, this is a possible password spraying attempt. And not only that, but it's coming from an IP that we've never seen before or in our environment. So that's what's happening there. Now I want to see, the attempts, and again, see if the person was successful or not. So I'm going to open this lead activity grid, and here I can see all the different attacks or all the different attempts, and this is sort of a view of the raw data of those attempts. And what's really cool here is that I can manipulate and slice and dice this data however I see fit based on the investigation that I'm trying to do. And specifically, the thing, like I mentioned, that I'm most interested at this point is, were they successful? So I can see this outcome reason field. And rather than look through all of these, what I can do is I can say, let's group by the outcome reason, and then go back over here on the left. And I can see all 36 attempts were failed because of invalid username and password. The next thing I might want to do is see who were the users that were attempted. And very easily, I can go here and say, here were the users all grouped together. And I can see there were only 2 attempts on all of those. So kind of a classic password spraying attack, very easily seen here within this grouping. So from there, okay, I feel pretty good about that. They weren't successful, but unfortunately, we see some additional activity from an IP address that was involved with a password spraying attack. Now this time happening on one of my hosts. This is starting to not look very good. So what we'll do is we'll go ahead and investigate this event. And here I can see the event, and I see that this host was accessing a known IP IOC. And in this case, this is the IP that was also performing our password spraying attack. And we can dig into some of the details here. But I see it was trying to run some PowerShell command, and specifically, what was it trying to do? And I can also see that it was associated with some IOC there as well. But I can dig in and take a look at what was the PowerShell command that it was trying to run, and it looks like it was trying to run a PowerShell script, and it's doing so with some things that maybe have me a little bit more concerned. Is like, hey, let's do it with an execution policy bypass. So now I want to maybe dig into this, because if I go back, I look at that and I see it's the IP address here. I might want to say, what's also happening on this host? And what Hunters allows me to easily do is I can go and click on the host. This is an extracted entity from this. I can find out, any of the information that we saw from kind of the deck of, who are the normal users for this environment? What do we know about the IP in this case? In this case, from the United States, which in my environment is probably normal. What's the user login history for it? But I might want to go and do a deep dive into the activity that I see here. And what I'm able to do is I can go and pivot to what's called entity events or host investigation. And I already have this up in my environment. But what this enables me to do is see all of the raw data associated with this host and an easy pivot. So I'm looking exactly 30 minutes before and after the event occurred. And I can see all of the individual raw data events. So this is data coming in from CrowdStrike raw telemetry, as well as a variety of other data sources. And see not only, again, the raw events as they've been ingested, but any other alerts that have been fired as well. And so if I just look at this screen that I pivoted to, I can see immediately that there's a critical alert, and it looks like this FOD helper was being leveraged here. And what I know about that is that it's often used to bypass UAC. So it could be a UAC bypass event. I'm not going to dig into that one too much right now, but it's important to understand that, we can start to see other things that are happening on this host. And now I'm getting a little more worried. But I'm going to go and look in the past and try to figure out, like, maybe where did that PS1 file come from that caused this alert to fire. And so the next thing I see, if I go a little bit farther up, is the suspicious bits event. And I know that that could be used to download files. So I'll take a look at this, and I can see, yeah, indeed, there's a bits admin transfer, and ultimately it's writing from a text file to a PS1 file. Seems a little unusual, but how did this process get kicked off, and where did it originate from? And so what I'm able to do here is dig into the process tree. And I can say, okay, well, let's take a look at what else happened in this process tree that might give me some more hints as to how this all got kicked off. And so I dig into here and I have my process tree, and here's my bits admin event here. And then I can see also the PS1 file. And so let's take a look at some other things that might have happened. And this is a particularly long one because Chrome can expand to quite a bit, but I can see that Chrome was running. And if I go down a little bit farther, I see that 7-zip was run. And if I click on the 7-zip event, I can see that a number of different files were downloaded or extracted from that 7-zip from that zipped up file. And so if I dig into here, the really nice thing is I have all my events and then broken down into different event types. So I can see specifically file system activity. And if I scroll to the right, I can see all the different files that were written. And this has me even more concerned because I see things like rclone.exe being written and PDFs with some unusual extensions on them that may not actually be PDFs. And so digging into this a little further, if I click on this Chrome event, I can see that it looks like the file in question, the zip file, was downloaded as part of, and it maybe originated from there. So I can see that this ZSL.7-zip file was downloaded from there. It was unzipped. Then, a process was kicked off to run bits admin, and then ultimately it led to that PowerShell being executed. So very natural pivot points in the product to be able to further my investigation from what was already correlated in my story. Diving into this a little bit further, though, we can follow this thread and see here we can see, okay, it looks like we were using that rclone that was unzipped from that zip file to exfiltrate data potentially to this file sharing website, which we don't use in our organization, and us obviously setting off red flags. And then going even further, we can see that new credentials were added to a service principal in my Azure environment. So now this person has pivoted to my Azure environment. And if I take a look at the credentials types that were being added there, I can see that a password was being added to that service principal. And then immediately after, I see that service principal being used to export a Azure deployment template. And I know that oftentimes deployment templates can contain secrets in them that potentially could be keys or credentials for different accounts. In this case, the deployment template that was being exported was this one called CTF-VM1 template. And sure enough, the very next activity that I see that's also associated with this, all tied together by this IP source client, is the use of a new Azure identity to run some remote PowerShell commands on this VM. And so if I wanted to dig into this, again, we can do so. Let me ungroup this. Open my alert here. I can see that it was using run command to run remote PowerShell here. Then I can pivot again to my entity search. And from my entity search for this particular host, which is a VM in my Azure environment, I can pivot from here, look for the run command activity, and then dig into that and figure out, well, what commands were actually run. And so here I can see the full process tree. If I again go into that process tree and go from the PowerShell that was created as part of that run command activity and look at the very next process that was run, I can see klist was run. And so probably not something that my users are doing naturally, and probably some way that this attacker is trying to exploit and find additional credentials that they can leverage to further move laterally in the environment. If I were to continue to pull on this thread, I would see a variety of other commands that were run via run command remotely on this endpoint as well. And then finally, we can kind of see that the very last thing that this person did, aside from signing in without an EDR, which we see that that's tied through all the way across the board here, is they've gone and added an additional extension to this VM. And the extension in question is this VM access agent. And the idea here is that this person now can leverage that extension to access this host whenever they want from a remote location. And so they've established persistence in my environment. And really, the goal of this was to kind of give you an idea of the type of enrichment that Hunters does, and also the type of investigation that it facilitates. And beyond that, the power that we have in being able to tie a variety of disparate events together. Again, I'm seeing an event that starts with a cloud-based password spraying attack. I'm pivoting to on-premise, then I pivot to the cloud, and then I change identities 3 different times as part of that. And all of that's automatically tied together and correlated, providing you with a very strong story that you can use to understand the full scope of attack in your environment. And with that, I'll pass it back over to Christian and, leave you guys with any questions that you might have that either of us can answer.
Thank you very much, Ian, for the insights. Wir hätten jetzt noch Zeit für Fragen. Sie können diese im Chat unten an WebEx Avante senden. Dann würden wir die Fragen in der Runde diskutieren. There is one question on integration of Defender suite. Is it possible to integrate Defender for endpoint and Defender for identity as well? So the different modules available?
Absolutely, yeah. We have a very deep integration with Microsoft products, and certainly, obviously in this case, showcasing, some of that in the Azure suite, but Defender for sure.
We have another question. Is Hunters Cloud only? And if yes, what are the available cloud locations?
Good question. Hunters is cloud only. We have a US location and we have an EMEA location. So those are kind of the 2 available that we have right now.
Probably I can add something to that. We are currently discussing with Hunters the options for Swiss-based hosting. And there is something on the roadmap. So if this is a topic, we can probably discuss it directly.
Absolutely. I think, if that's something that you're interested in, let's have a further conversation and definitely not let that be a limitation.
Dann würde ich sagen, schließen wir die WebEx für heute. Vielen Dank für Ihre Teilnahme. Wenn es Fragen gibt, dürfen Sie sich natürlich jederzeit direkt auch bei mir und Ihnen melden. Vielen Dank. Schönen Tag noch.